basically we are applying data analytics techniques for supporting policymakers or decision makers in business and companies. So we have very close relationship with Turkish partners through EU-funded project. For example, we are working with Istanbul Technical University, Sabancı University in Istanbul. Also, we are working with Ankara Development Agency and Eastern Marmara Development Agency. Also, we are working with Turku satellite. So this project is not with the Turkish partners, but this project is with Qatar University, Georgetown University in Qatar and Western Sydney University and also Cranfield University. So this project is about applying qualitative data analytics to help policymakers to identify what is the major reason for food waste from food supply chain and logistics in Qatar. So we are applying Fuzzy cognitive math, which is a qualitative data analytics technique. So probably this is one of the technology to support policymakers among the many different stakeholders in food supply chains. Okay, I skipped the definition of food security. Basically, there is an important dimension like availability and access and utilization and stability. This is a kind of initial survey about the food security in Middle East area. Here, you can see most of the countries very high level of insecurity, apart from Saudi Arabia, Qatar, and some Oman. But after political uprising in the Arab world, they again had a survey, and then surprisingly, Saudi Arabia and Qatar, who were supposed to be very high food security level, citizens are feeling they are really one of the worst citizens are feeling insecure about food security. The major reason is, for example, Qatar is mostly relying on importing food. They are only generating 7% of their total demand. So therefore, also they are importing more than 90%, and their water is mostly using desalinated water. So this kind of circumstance make the Qatar government very sensitive about securing food security, and particularly reducing the food waste. So basically, Qatar is one of the second highest obesity rate in the world after the United States. So their food supply is quite good, but more than half or 50% of the food actually are wasted. And combined with their 90% of the food imported from outside, this provides very weak food infrastructure and security issues. So one of the major challenges is how to change, how to reduce the food waste so that if something happens, for example, war, what is kind of political turbulence, they can sustain with minimizing their food waste. So this is a basic objective of our Safe Cure project, and so we're funded by Qatar National Research Foundation, and the major goal is to identify the major factors and causal relationship between such factors, and identify some policies to reduce total food waste. So how we did a workshop by inviting major stakeholders in food supply chain in Qatar, including the government people and also company people who are involved in the logistics and supply chain, and also the farmers who actually producing the food, and also companies who make import, including the logistics. So we made some basic questions about how, because they are of course one of the best persons who know how the food is wasted during the whole stage of the supply chain. And through the workshop, we prioritize some factors, and then we come up with this kind of causal effect relationship, which identifies all the participants of the workshop. So we use computerized simulation tool, which is developed through one of the European projects. For example, there are some in the middle F20 food waste, and there are some other factors derived from food supply chain and logistics, and also government regulations. So also we identify the strengths of the causal relationship between factors. Therefore, we can conduct kind of simulation. So if we can try to change the current level of input control or some education level of the staff, and then we can see how the food waste can be dropped through manipulating different factors and concepts. So through this simulation, we came up with some insights that can be implemented by policymakers. So I will go explain the details. This is just an example of how the qualitative data analytics can be used to support policymakers in food supply chain.
Ladies and gentlemen, the last one. So, my name is Colin Moffat, and I work for, it's jumping again here. I work for Marine Scotland, up in Aberdeen, which is well away from here. And what I'm going to speak to you a wee bit about is sustainable agriculture. And we did hear something about agriculture earlier on today. Actually, do you know that with 70% of the surface of this Earth covered in water, calling this planet Earth is wrong. We should call this planet water instead. Because actually, at the end of the day, the marine environment is where we're going to make the difference in terms of supplying the high-quality protein that's needed to make up the growing population that's coming across us. So I'd just like to very quickly dip into agriculture, but I will, oh, there's something peeling but it won't be too long. So it's a global industry producing about 101 million tons of fish, shellfish, aquatic plants, and other aquatic animals in 2014. Of that, about 74 million tons is animals, and of that, about 47 million tons is produced in inland agriculture, and about 27 million tons is produced in mariculture. It's worth about $166 billion globally, which at the exchange rate in 2014 is 102 billion. I don't know what the exchange rate is today, but it probably isn't very good. And it takes place in all sorts of water. It takes place in fresh water, salt water, brackish water, you name it, we grow in it. Agriculture, often people think agriculture is new. But actually, agriculture dates way, way back in China to 3500 BC. So it's an old industry which has found a resurgence in the last 40 or 50 years. And why is that? for several reasons. First of all, it produces the N-3 fatty acids, which are so important for our diet. We should all, how many eat fish? Yes, yes, yeah. Get in these N-3 fatty acids, forget about the N-6 ones from your sheep and cows and all that sort of stuff. Get in the N-3 ones. And as I say, it's going to fill the protein gap, a protein gap which is going to be massive by 2025. And if we have a quick look at a comparison of the 2013-2015 average agriculture production, what we're predicting it needs to be in 2025, this is globally, and this is from FAO figures for this year. What we're seeing is in terms of agriculture production, we have to move from around 44% to 52%, and in terms of global fish consumption, we're going to have to move to 57% being produced from agriculture. And this is in part because for the last 10 years, 15 years, marine catch fisheries has stayed static. It's not increasing, and therefore we're going to have to do this from agriculture. Now, oops, this thing keeps rolling away, so I'll pop it down here. And it's going to come out, so don't worry. No. There we go. Whoops. Right, okay. Now, this is agriculture from 1975, and the blue ones are Scottish. Our agriculture industry, which is mainly finfish, mainly salmon, and it went up to about 2005. We had a wee bit of a dip here, but it's taking off again. Compare that to the USA, to channel catfish, and again it's been growing until about 2004, and it's now a wee bit in decline. And then if we look at the Philippines now, tilapia, well, that's a good story, isn't it? Starts here, goes up, we dip, look at the way it shot up in 2005, 2015. So what we see is that depending on the species, actually depends on how it's performed. But in Scotland, we have great ideas for agriculture, partly, hopefully, engineered by the Scottish Agriculture Innovation Centre, which is going to power things for us, I hope. But actually, what we're going to do is we're going to see a doubling, hopefully, of our finfish production in Scotland. Because, I don't know how many of you know, but our Scottish diet is pretty poor. We need to eat a bit more fish and stuff to reduce our heart problems. And so we need to get that right. In Scotland, how many of you know where Mars bar is? Yeah, well in Scotland we eat deep-fried Mars bars. It's the most disgusting thing ever. Don't worry, I eat fish. Right, now, I did read your research. This is your production here, and an upward trend. This is both your inland aquaculture in terms of your rainbow trout, which you eat apparently mostly, and you can tell me if I'm getting any of this wrong, okay? You eat most of your rainbow trout within your country, but you export most of your sea bass and sea bream, about 75% of it you export. So if you can increase your sea bass and sea bream processing and aquaculture, you can export, and you can get that out there. But also, get all that trout growing, double your production, and again, get that protein into the diet for people. So a nice trend there to 2015. Now, what are the issues? The main issues in agriculture are disease, whether it be viral, bacterial, or parasites. And what we see here is some of the diseases, especially top one associated with our fish farming in Scotland, and that's that little thing called a sea louse, which is only about this size when it gets big, but it causes huge problems globally. In fact, the sea louse is a big problem. In Norway, they lose about 34 million fish every year to disease. 34 million fish every year to disease. In Scotland, sea lice is the biggest problem. But the other thing is that we have got a lot of existing diseases, for example, infectious salmon anemia, which in Chile wiped out its disease, wiped out its salmon farming industry in one season. In Scotland, we've had 2 doses of infectious salmon anemia. We learned from the first, and the second one hardly had any impact at all. And so it's all about learning from what's going on. Amoebic gill disease, that's a new disease that's coming through, present also in Australia and Tasmania. Pancreatic necrosis disease, shrimp, red egg disease, these are all new diseases. So we're getting emergent diseases coming through. But the other thing is the impact of a changing climate. Our climate has always changed, but it's changing more now than ever before. What's going to be the impact on pathogens? What's going to be the impact on parasites? What's going to be the impact on where we can grow the fish? Because in Scotland, we're just about at the southerly latitude of where salmon can grow. And if it gets too warm, salmon can't sweat. They just have to go somewhere else. So what might we bring in to replace the salmon? In Turkey, what might you do if the Mediterranean, because most of your marine aquaculture, so in the Aegean, round about there, what are you going to do if that heats up too much? And the fish, the sea bass, the sea bream can't accommodate that. So how are we going to do that? But it's a combination of changing pH, of increasing in temperature, will affect the pathogens. And so you've got to understand the pathogenic diseases that are happening. In terms of common disease states, I just did a quick calculation. In terms of salmonids, there's 16 very common disease states. In terms of the sea bass, which you have, is 14, and the gillhead sea bream, that's 9. So across the 2 species that are most common to you in your marine aquaculture, you have at least 23 disease states to deal with. And that's a lot, and that's a big problem that you're going to have to deal with. Now, how are you going to tackle this? Well, this is Norway, although it's not actually Norway, it's a growth profile for going from, at the start of the Norwegian aquaculture industry, mainly salmon, from there until 2014. And you can see that the industry started small and has shown a very successful growth curve. The green bars here are the use of pesticides. And what you see here is that for practically no growth, no salmon, massive amount of pesticides were used. But they got better at cultivating their salmon, and the pesticide use came down to about 0. But now look what's happened. The pesticides are again having to be used because of drug resistance. So we've got to be very careful that drugs, pesticides are not the answer to everything. We've got to look for other methodology. And this is where collaboration can really come in. Yes, we will never get rid of using some sort of pesticides, but we've got to do something else. And that's, we feel, in Scotland, the key to growing our agriculture industry. It's not going to be pesticides, it's going to be these sort of things. So reducing stress through changes to the husbandry. And that means looking after your fish. And that can be quite a challenge, but that's what we've got to do. In some countries it means clearing the ponds for inland aquaculture first before you restock. We've also got to improve the environmental conditions, so the stocking density, absolutely fundamental in terms of your growth and what's going to happen. Remember, salmon, and generally apart from our pelagics, they don't actually live in big communities, and we're forcing them into these cages of mass numbers of fish. And for the likes of sea lions, it's like coming to a banquet. You sort of go, wow, here's my dinner, all 10 courses in front of me straight away. I don't even have to do anything, just hop from one to the other. And so that sort of thing means that you've got to think about environmental conditions. What's the water like? What's the oxygen like? What's the temperature like? And how does it change? during the day. Cooperation between farms within a geographically connected area. As you probably all know, water moves. And if water moves, it means everything's interconnected. And so if you've got a farm here, it could be connected to a farm over here and over there. So what we do is we undertake extensive modelling, hydrodynamic modelling, to assess where disease might go, where the pathogens might move to. And then say, well, there's no point putting the farm there, because that's where the pathogens are going to go to from that farm. And when we do a treatment, if you do a treatment, you don't just treat the one farm, you treat a group of farms through having area management agreements. And also, if you have a farm fallow, you try and fallow all of our farms that are interconnected. So it's all about changing what you're doing and tying it in with marine planning. Because what we want to do is we want to use the marine environment, renewables, tourism, all the rest of it. I've never been to Turkey yet, but apparently it's great for tourism in that. Great beaches. We've got nice beaches in Scotland, but they're freezing cold, so you don't want to go there. Consider all the human uses. Now, the other thing is bioremediation. Can we use nature to bioremediate pesticides that we put in? Or can we use nature to deal with the parasites? And so to that extent, natural predators. Can we take natural predators, Ballan wrasse, come in and have a wee munch of the parasites? The problem is that there's not enough parasites often to keep the Ballan wrasse fed. So you've got to balance feeding the wrasse against them being hungry and wanting to eat the parasites. So there's all that sort of stuff that you've got to get right. We're going to try improving host-resistant disease through vaccines. That won't work for shellfish, of course, because they don't have the same immune system. Novel treatments. We discovered that actually if you give the salmon a wash in a wee bit of warm water, the sea lice don't like it. So that's good. And so there's all these sort of things which we're trying to do. And so if we can get that right, hit the run, hit the water running, solve issues in aquaculture, and the key thing is we want to be multidisciplinary and